Good afternoon, Algebra 2. Welcome back. We're going to talk about section 5.6 in these videos. And this is going to be the last section we cover in chapter 5. We're going to finish up our discussion about polynomial functions for a little bit. We're definitely still going to be using polynomial functions, especially in the next chapter, chapter 8, when we talk about a new type of function, okay? So let's go ahead and finish up. The idea behind section 5.6 is to give us a little more practice, okay? If you look at the title, it says find zeros of polynomial functions. We've been doing that. We've been doing that in 5.4 with factoring. We learned a little bit more factoring techniques just now with general polynomial function. And then with 5.5 and 5.5, we learned about, sorry, I forgot that I split 5.5 into two sections. In 5.5b, we use synthetic division to kind of talk about how that can help us to find and fully factor a polynomial function to find the x-intercepts and zeros and etc. Okay, so really this is a section for us to take an opportunity to get more practice. Okay, more practice with the stuff we've learned so far. You're gonna find that synthetic division is gonna be the thing that we use a lot. Okay, and that's really good because synthetic division, we like synthetic division compared to things like long division and some of the more crazy factoring things we've had to do. Okay. So our objectives for this section, our last section of chapter 5, is to get more practice with synthetic division. We're going to be masters at synthetic division by the time you leave my class. Miss Bain will be very happy with that if you end up going to pre-calc next year. Use a mix of synthetic division, factoring, and the quadratic formula to find all the zeros of a polynomial function. Okay, we're going to talk about kind of why I make that distinction there. And then we're going to use decimals and the fundamental theorem of algebra to confirm our solutions. Okay, so we've been kind of just lately just getting a lot of answers, and we haven't really been doing a whole lot with them in terms of, what do our solutions mean and why do we have more than a few solutions? I know in class you guys asked the question one time, well, how many solutions are we going to have sometimes? And I told you, sometimes we're going to have 5, sometimes we're going to have 4. Later when we do trigonometry, that's going to jump up a little bit, but that's going to be later in the semester. Um, so this will give us an opportunity to talk about why, like why do we have more than just one or two answers like we're used to seeing, okay? So a little bit of clarification, some kind of distinctions we're going to make that are going to be important as we kind of finish up chapter 5, okay? So what am I talking about? I'm talking about, so let's say whenever I ask you to find, I'm going to divide this up a little bit. Whenever I ask you to find x-intercepts or real followed by lots of different words I can put here. I can put real solutions, real zeros, and then real roots. Okay, whenever you see any of this terminology, I'm asking for only real numbers. Okay, and that's going to help you on homework assignments, like on the last few practices we have left, and on next week's midterm, because sometimes I'm not going to always tell you right off the bat, like when you're taking the midterm, I'm not going to say, oh, in number 2, I only want real numbers. It's really up to you to determine whether or not it's just going to be real, versus if I ask you just to find all solutions or all zeros or all roots, right? If I ask you any of this right here, then that can includes both real and complex values. Okay, so if you remember from section 5.4, when you factored and you found x-intercepts, there were times where some of the factors were, say, x squared plus 2. And you didn't bother with this at all, because when you solved it, like say, x squared plus 2 equals 0, you got x squared equals -2, take the square root, plus minus, we get x is equal to plus minus the square root of -2. And then right here, I told a lot of you to just stop, to just not keep going. And the reason why is because this is not a real number. This would give us plus or minus I root 2. And that's not a real number, which means it's not an x-intercept, right? Only real numbers are x-intercepts because we're graphing in the real coordinate system. Okay, so whenever, like, kind of be able to make this distinction, when I ask you for x-intercepts, I don't need to have the word real in front of x-intercepts, because if it's an x-intercept, it's implied that we're graphing it in the real plane, in the real coordinate system. Okay, now with the word solutions, zeros, and roots, I do need to put real in front of it if I want you to only find the real ones, okay? When I say all, that's going to include your real and your complex, okay? Now remember, just to recap, real includes your whole numbers, it includes your decimals, it includes your radical values, and it also includes your fractions, okay? So all of this is fair game. If that's in your answer, then that's real. As soon as you attach an I to any of these, it's no longer real, okay? Hopefully that distinction makes sense, and hopefully you're confident enough on the midterm to be able to make this distinction whenever I ask you questions like this, okay? Let's get into an example, okay? We'll do one example for this first part of the video, just to kind of show you what's going on, the ins and outs, and then we'll go ahead in the next part, do a few more examples, okay? So let's find the zeros, and I kind of already made a mistake, so, oh, wrong button. Not a mistake, but I left something out, so find all these zeros of f of x equals 2x cubed plus 8x squared minus 6x minus 28, given that f of -2 is equal to 0. And we're going to check our work using decimals after we're done, okay? So we're finding the zeros, we're finding the x-intercepts, and they give us a piece of information. And we're gonna find out that we need this piece of information, because if we don't have it, we can't do much with this, okay? So normally, if I just gave you this polynomial right here, and suppose I did not give you this piece of information, this f of -2 equals 0, your only option would be try to factor it. And if you try to factor this, our only option is to use factor by grouping. And if you try that, you're going to find that you can't successfully complete it. Okay, so we have to rely on other methods. They need to give us this piece of information, f of -2 equals 0. Well, what are we going to do with that? Well, remember back in 5.5b, f of -2, what does that mean? And we don't need 5.5b to know this specific part, but this just means that, I plugged in an x value and it gave me 0. That means that -2 is a 0. It's an x-intercept, right? So, and if that's the case, then we know x plus 2 is a factor. Oh, I should be doing this in a different color because now it's blending with the example, but that's okay. Okay, we know that x plus 2 is a factor, which means that we know that x plus 2 divides into f of x evenly, which means we can use synthetic division and know that it's going to give us a nice result. So let's use synthetic division to find the rest of the zeros. Okay, let's set everything up. We take the opposite of the constant term of our divisor. Our divisor is x plus 2 because it's a factor. So we have -2 in our little shelf. Line up our constants. What are our constants? 2, 8, -6, and -28. We don't need a placeholder here because we have all the terms. -28. And then we draw a horizontal line underneath, which will be our answers. Okay, always, always, always bring down the leading coefficient. Okay, let me do the answers or the coefficients in a different color. So 2. -2 times 2, that's -4. 8 plus -4, that's 4. -2 times 4, that's -8. -6 plus -8 is -14. Okay, hopefully you're remembering how to do this from 5.5b. We add downwards, and then we take the -2 and multiply every single time with these numbers below. Okay, remember those arrows we used a lot when we were first learning this. Okay, -2 times -14, that is positive 28. And good, we've confirmed that it is definitely a factor because we got a remainder of 0. happy face because everything went well. All right. So we know x plus 2 is a factor, so we know that we can rewrite this polynomial as x plus 2 times a bunch of stuff, and we found the stuff, right? Remember, this is our x cubed term, x squared, x constant. Our answers are reduced by 1 in terms of degree. So now this is x squared, x constant, remainder, which is 0, thankfully. So then this is 2x squared plus 4x minus 14. Okay, so now let's go ahead and we factored this. We can try factoring a little bit more, but this is asking us to find the zeros. Okay, whenever you're too lazy to factor, or whenever you kind of don't know if you can factor this immediately, we can just kind of skip a little bit of a step. So we know, first of all, let's kind of just make sure we're keeping track of our information that we found. Okay, we know that this is equal to our function. Okay, this function and this factored form, they're the same. Okay, and you can prove it to yourself by multiplying this through if you're not convinced. Okay, so since we want to find the zeros of this, we would technically set this equal to 0, but this is nicer because now this is something we can use zero product property with. Okay, so I can say x plus 2 equals 0, and 2x squared plus 4x minus 14 equals 0. Okay, normally I would factor this first, but setting it equal to 0 immediately will kind of let us know whether or not we can factor, and if we can't, then we can immediately jump into quadratic formula. Okay, so this first one, subtract 2 over, we get one of the zeros is a negative 2. But we knew that already. That was from this right here. That was from this and this. We knew this one already, so this is not any new information. Okay, these are the same thing. Okay, this negative 2 is a 0. This is that exact negative 2. Okay, so our new zeros, the ones we don't know, are going to come from here. Okay, so always, first things first is see if there's a GCF. What do we have? Well, it looks like 2 can be factored out as a GCF. So we have x squared plus 2x minus 7 left over equals 0. We can divide this 2 over just to get rid of it. X squared plus 2x minus 7 equals 0. Now, can we factor this? Are there any factors of negative 7 that I can add up to get positive 2? Unfortunately, no. So we have to resort to our quadratic formula. Okay, so x is equal to negative b, so this is a is 1, b is 2, c is negative 7. So negative b, negative 2, plus or minus the square root of 2 squared minus 4 times 1 times negative 7, all divided by 2. Negative 2 plus or minus, this is 4 minus, actually then becomes plus 28. So that's 32 over 2. Okay, I'm running out of room, so I'm going to keep going over here. Negative 2 plus or minus. Can I simplify this rad 32? Yes. Rad 32 is equal to square root of 16 times 2. Remember, think about your perfect squares. What's the biggest perfect square that I can divide into? That way I can have an easier time simplifying. So then that is square root of 16 times square root of 2, which is 4 rad 2. Okay, so plus or minus 4 rad 2 over 2. Okay, notice that I can divide this 2 into both parts. So I get negative 1 plus or minus 2 rad 2. And that is my other zeros, okay, plural, because notice that this is technically x is equal to negative 1 plus rad 2. Oops, sorry, 2 rad 2. My apologies. 2 rad 2. And x is equal to negative 1 minus 2 rad 2. So 1, 2, 3 different answers. Okay, those are all our zeros. There's a lot going on, so let me actually use a different color to show what our answers were. Okay, I'm using orange. Our answers are x equals negative 2, because that was not only what we got from here, but that was also just given, right? I gave you a 0 for free, so you already knew it. And then I got another one and another one, both of these coming from this, which came from the quadratic formula, okay? So that was kind of a recap of the math that we just did. Right now, it looks like a disaster. If you need to rewind this video a few minutes to see kind of where each piece came from, I encourage you to do so, okay? Hopefully that sounds okay. And notice that we got one nice whole number, and our other two are real numbers still, but they're, there are irrational numbers, right? Because they have a square root that's not nice. So both of these are irrational, but they're still real, right? Irrational numbers are still real. Okay, so we found all the zeros of this function, and we found three. Okay, three solutions for a degree 3 polynomial. There's a very nice theorem that kind of shows the relationship between the number of solutions and the degree of the polynomial, and we'll talk about that in the second part of this video, okay? So meet me there so we can continue our discussion.